So this is a few things that I want to cover, right? These reactions I'm getting straight from the Alkene reactions PDF file that Yasmin uploaded on Canvas, right? Um, I know it's a lot to digest. Like, you're supposed to know there's a lot of mechanisms that are out there. This is just a way to condense everything, right? So alkene renditions, double bonds, right? You can see right here, the first reaction I did was oxymercuration reduction, right? You don't need to know the names of all these reactions, but you do have to know this, right? You have to know this and this, right? The reagents, right? The how to do the reaction, right? Because she might do this, right? She might say, "Hey, how do you get from there to there," right? And you have to know, like, "Hey, you have to do this, or you have to do something else," right? So the major thing that you have to know about this reaction is it adds an OH and an H plus anti to the double bond, right? Meaning in different planes of the double bond, right? It's a Markovnikov addition, meaning that the OH has to go to the most substituted carbon, and you don't need to know the mechanism, and you get a racemic mixture, meaning you get both enantiomers, right? If this was RNS, then the enantiomer has to be SR, right? As you can see right here, the OH and the methyl from right here, right? This translates from right here, right? Here's the OH, here's the stuff that we added. See how the OH and the H are on different planes, right? Because this is a anti-addition, right? An anti-addition of an OH and an H across the double bond. Similarly, we're going over here, right? Here is this, the same molecule, right? The deuterium. If you don't know what D is, deuterium is just H2. It's just a proton and a neutron. It behaves the same thing as an H1, right? This has a higher priority than that because it has a higher atomic number. So here's the same molecule. This is called hydroboration oxidation, right? BH and THF, OH2 and OH minus, right? You have to know this, right? You don't need to know the mechanism. You do get racemic products. The only thing that's different, you add an OH and an H plus across the double bond, right? The only thing that's different is that it's non-Markovnikov in the syn addition, meaning the OH is going to go to the least substituted carbon, and the syn addition meaning that the OH and the H plus are going to add on the same plane of the double bond. So I'm going to write the products of this guy. It would be this, right? I'm going to draw my ring. First of all, I would suggest doing flashcards of this and just say, hey, I had to know that's a racemic product and stuff like that. Same plane of the paper, right? So the OH is going to add here, right? Because it's non-Markovnikov addition, right? It's going to add O here, and the H has to be right here, right? So if the OH is right there, right here, right where the deuterium is, and the H is going to be over here, same plane, right? What does that mean about my molecule? Then that means the deuterium has to be going into the paper, and the methyl has to be going into the paper as well, right? Syn addition of OH and H, meaning same plane of the paper, right? Or same plane of the double bond, right? You have these two going in the back, and it's racemic, so I just put plus enantiomer, right? Like, if I were to send a priority, I had to send chiral centers, right? Here's absolutely, these two are chiral centers, right? So this is priority for this one. This is priority number 1. So this is the first priority, right? And this is a third priority, right? This is my third. Here's my fourth, and here's the 2, right? So this is if you want to assign priorities, 3 is going into the plane of the paper. 1's going in the plane of the paper. 4 is going out, and you have 2 right here. I'm going to choose to leave 2 or I'm going to leave 1, 2 in the plane, right? I'm going to rotate the rest. So I'm going to leave 2 the same plane, right? I'm going to rotate the rest. here. So one's gonna go, I want 4 to go in the plane of the paper, so 4 is going over here, so 3 is going to go over here, and 1 go over here, so this is a 1, 2, 3, and counterclockwise, this is going to be an S, right? This one, you're going to have 1 right here, right, first priority. This has to be, it's between this and this, it's between these 2 carbons. I would say that this is number 2, right? This carbon is number 2, so 2 is in the plane of the paper. Deuterium has to be absolutely number 4. This carbon has to be 3. So this is a 1, 2, 3 counterclockwise S, right? So this is an SS, so the enantiomer has to be RR, right? Same logic applies, stuff like that, right? So you don't need another mechanism. You get a racemic product, meaning you get both enantiomers 50-50. Adds an OH and an H plus across the double bond, non-Markovnikov's in addition. Something you just have to memorize, right? The next reaction, let's use the same molecule, right? And I will be posting these notes if you need to see them. The next reaction you absolutely have to know for this next test is this, right? Same molecule, right? That's double bond, methyl, deuterium. The next reaction on that list is, ozonolysis, right? Ozonolysis, which is an oxidative workup, right? So ozonolysis, it's a very violent reaction. This, right? You don't need, no mechanism required. And this is going to cleave the double bond and add ketones or aldehydes. That's an aldehyde, right? Meaning that what this molecule ozone, right, is going to do to this double bond is going to cleave it in 2, right? And I would number my carbons when you're doing this, right? I'm going to say that this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and so on, right? 1 through 5, right? 1 through 6, right? So 6 has the deuterium and 1 has the methyl. So what this is going to do is break apart this ring, right? And let me put a star right here. She's absolutely going to ask you a question about this, right? So you have to go backwards and forwards. So I'm going to make a 6 carbon chain. 1, 2, 3, 4, 5, and 6, right? So where are my double bonds? It's right here, right? Here's a double bond right here. Here's carbon number 1, 2, 3, 4, 5, and 6, right? 6 has the double bond on it. It used to have the double bond in it. It has the deuterium on it. And this has the methyl, right? So, as you can see right there, there's the methyl, right? Carbon number 1 translates over here. You see it still had that methyl where the double bond was. It basically cleaves the double bond and you add an O on it, right? And be careful with this reaction because if this were a hydrogen, right? The deuterium were hydrogen, you get an OH because it reduces it completely. But if you had, let's say, same rules apply if you had like this, right? If you had in DMS, right? Oops. DMS. Same logic applies, but you don't get full reduction of, let's say, like if this were H, right? So that's the next reaction you absolutely have to know. Let's see here. You don't need to know free radical. Don't any radicals you don't need to know for this class, right? You don't need to know the mechanism for this. You need to know the going forwards and backwards, right? So if she says, okay, what reaction did you get from that, right? You're gonna have to work backwards and say, oh yeah, I got a ring. So just practice, right? Next reaction you absolutely have to do and know, right, is acid-catalyzed hydration. So same molecule, my deuterium. It's in the name, right? Acid-catalyzed hydration. So I'm gonna add water and acid. Water and acid, right? So this is gonna add an H and an OH across the double bond. It's a Markovnikov addition. And the stereochemistry is non-selective, meaning we get scrambling of stereochemistry, and this is an app you have to know the mechanism, right? No mechanism. So you're gonna have to know the mechanism, right? You're gonna have to know why why there's no regiochemistry, right? Regiochemistry. So this is gonna protonate the double bond, right? You have to know this mechanism, right? And intermediate is the carbocation, right? So if there's no regiochemistry, that means OH and H across the double bond, no regiochemistry. You have to know the mechanism. I'm not going over that right now. That's just something that was in the last exam, right? So I can just do this, right? If I'm not going to define stereochemistry, I can just do this, right? And this is just a way to show that the lines, right, is just saying, hey, this could basically do anything, right? It can add it right here, or it can add in the bottom, right? It can do either or, right? So just volatile reaction because of the scrambling chemistry of this cation, right? This cation of this empty p orbital, right? So let's move on, right? Next reaction you have to know is Hydrohalogenation, which is a mechanism they absolutely have to know. It's on the last exam, right? I think it was on the last exam. Yeah, it was. Hydrohalogenation, right? Hydrohalogenation. Ignore that. Hydrohalogenation. So here's our deuterium, right? If we forget that, this is a Markovnikov addition of OH plus H. No regiochemistry, because you get a regio, right? No regiochemistry, and because you get a proton, right? What is the intermediate of this guy, right? It's a proton, right? I mean proton. Carbocation. So you get a carbocation, right? Sorry. Whew. Excuse me. And you have to know the mechanism. And this was on the last exam. Same thing here. So it's a Markovnikov. Most electronegative is going to add to the most substituted carbon. No radiochemistry because you don't need to know that, right? And as you can see right here, right, because of that intermediate, right, the intermediate looks like this. And we don't know how this adds, right? We can add on top, we can add bottom, you get all sorts of things, right? You get product mixture, right? Okay. Last reaction, you absolutely, oh no, never mind, not the last reaction. The next reaction you have to know is hydrogenation, right? Hydrogenation. You don't need to know this mechanism. The same. You can do this with platinum and let's say like some catalyst, right? Or you can do this with radium nickel, or just look at your lecture notes and look at the different things you absolutely have to know, right? This is a syn addition of H, right? And I forgot the deuterium right there. And syn addition, right? No radio. So if it's Markovnikov or Markovnikov, there is none, right? And I think you get enantiomers on this one, right? Because since you add a syn addition of this and this, it can add either or, right? So you get a racemic product. Okay. So I'm gonna add two H's on the same plane of the paper because it's a syn addition of two H's, right? What does that mean about this guy, right? It's in the plane. It's going into the plane of the paper, and then methyl. So is the methyl, right? And same logic applies. Plus enantiomer. Racemic mixture, syn addition of H2, easy, right? Memorize this reaction and easy, right? Next reaction. No mechanism, right? You don't need to know the mechanism. Going over the 20-minute mark. That's terrible. Okay, the next reaction you absolutely have to know is halogenation. And this could be any like Br2 or Cl2, right? So hydrogenation, sorry. Halogenation, right, is a syn addition of Br2. You need to know the mechanism. It's Markovnikov, but it doesn't really matter, right? Because it just adds Br2 to the same thing, right? But you have to know it's an anti-addition. Anti-addition, right? So that means that two BRs are going to add on different planes of the paper. How do you show that? You need to know the mechanism. I'm not covering that right now because you can do that in your own time. Or you can come to my office hours, right? You can come to my office hours and we go through this reaction. But it's also on that worksheet. So you're gonna add BR like this, different planes, right? So this BR is going into the plane of the paper. That means that the deuterium from this side, right? From this side is right here, and the methyl is going here. Plus an enantiomer, right? Because it can add either or, right? You can have the BR going out, or you can have the no plus an enantiomer. Be careful with that, right? Because let's see here, and the other product would be this. Is it an enantiomer? I think it is an enantiomer. I would check with Dr. Cameron. This is an enantiomer, right? But just be careful, right? CH3. So you get these two products, right? The next reaction you have to know the mechanism for this one. So is sort of the same reaction. And this is Br2 and H2O. You have to know the mechanism for this guy. Same logic applies, but this is a Markovnikov. Which one's the more electronegative, right? O or Br? It's O, right? O is good. Oh my! Basically, water is gonna add right here, and you're gonna deprotonate, right? But this is an anti-addition of Br and OH minus. You have to know the mechanism, and it's Markovnikov. It's Markovnikov. What else is it? Anti-addition of Br and OH minus. Know the mechanism. Markovnikov, meaning the OH is going to add to the most substituted carbon. And I think it's a racemic mixture, meaning you get both enantiomers. Same thing here, right? But this one right here, right, is an OH, right? Anti-addition, deuterium, methyl. Right. Plus an enantiomer. So those are all the reactions you have to know. You have to know the mechanism for these two, right? You have to know the mechanism. Just go back through the video, right? Dr. Kimber has examples of how to do those. Yeah, so just a heads up, right? Just know those reactions. I'm getting these reactions off of the Alkene rendition PDF file that Yasmin uploaded. It's on campus under announcements. And yeah, just good luck.